Thanks for downloading a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online. Now stay tuned for your 3CR podcast.
Welcome to another episode of Lost in Science. It is half an hour of science coming at you out of the radio, hitting you hard for the next 30 minutes, or maybe a bit less. I think we kind of live with the gap for some music there.
Give or take.
Yeah, give or take, 30-ish. Look, it's more, it'll feel like more than 30 minutes though. There's going to be so much science, it'll be jam-packed. Your brain,
much interesting science. Your brain will
cope, I hope. My name is Chris, and I am talking about a thing that, I try to avoid talking about like internet controversies because there's usually a lot of rubbish. But this one, people get really excited about. You probably heard about. It's the new NASA Impossible Space Drive.
Oh, yes.
Yeah, the EmDrive or the EmDrive or however it's pronounced.
And that it's gone to peer review and people got excited about it.
Yeah, there's a peer-reviewed paper published testing this supposed impossible device that will allow something to move without any propellant. It's like a magic rocket ship. I'm going to talk about what it is and why it probably doesn't work, but also what the situation is of the status of the research, etc. What's interesting about it, and what the I guess being part of the physics conspiracy, what we don't want you to know. That's what I'm going to tell you. Stu, impress me. What do you got for us today?
I'm going to be talking about how students don't want to study science anymore. And the numbers of science students are declining.
Are they?
Across the board. Yes,
I
unfortunately.
would expect them to be going up because of all the good work that we do.
Well, absolutely.
Exactly.
But apparently student numbers are falling in science. And it's kind of the time of year when students finishing their last year of high school will be getting results and thinking about what courses to apply for. So hopefully I'll convince some of them to look more closely at science courses.
And hopefully if they do their science courses, there'll be jobs for them when they graduate. But that's another story entirely, I suspect.
The sad truth of
peripheral,
my life.
but still related.
We'll solve that one. We'll just give them a few years to study, then we'll fix that by the time they get out. Anyway, on with the show. Yes, you are listening to Lost in Science, and I am talking about the EmDrive, or possibly EmDrive. I've seen it spelt with like a small m as well as a big M. Also known as the RF Resonant Cavity Thruster, and it is the impossible NASA space drive. Probably all those words should be in quotation marks. Have you heard about this?
I have heard about it.
I haven't, but it sounds cool. Thruster.
So
like it.
It's supposed to be some sort of propulsion device that can power a spaceship through space, but it doesn't actually need, the heavy fuel loads and things that current technology has. Is that pretty much what it is? That's
pretty much what it is, and it does that by the simple mechanism of violating the laws of physics.
I see.
Simple.
Simply.
Which I think we'll all agree was the big obstacle. That we've basically been obeying these laws, and that's where we've gone wrong in the first place. But look, what is this thing? This thing was invented by a British bloke called Roger Scheuer, and shortly after, the same idea was come with by an Italian Guido Fetta. He called it the Cannae drive. As I said in the introduction, it's hit the news again recently due to there are some tests run by a NASA team, and their results are going to be published as a peer-reviewed paper in the Journal of Propulsion and Power. And of course, being this kind of impossible kind of technological thing, the internet loves it, has gone crazy for it, and there's been a lot of discussion. So I thought, I would address this. Now, what this thing is, it's basically kind of a cone-shaped cavity, little cone-shaped box. It's a truncated cone, so it's like flattened at one end. It's got a microwave generator attached to one end. And basically, due to the cone shape, the electromagnetic fields that are created by the microwave generator, they aren't symmetrical, and supposedly as a result it pushes it forward in the direction of the cone when you switch on the microwaves. That's the whole deal.
So it's a microwave propulsion device.
Essentially, yeah.
Right.
But the microwave generator is attached to the cone, so it's a bit like having, say, for instance, a boat with a sail and then a fan on the boat that blows the sail and pushes the whole boat forward.
Like a Wile E. Coyote contraption.
A Wile E. Coyote contraption, or something that I may have, drawn in my sketchbook when I was a little kid.
Yeah.
Before I understood about Newton's laws of motion. Because that's what the problem is here. It violates Newton's third law of motion, which is the whole for every action there is an equal opposite reaction kind of thing.
It's basically like a version of a perpetual motion machine.
It's very similar. It's not free energy because you are putting energy in with the microwaves, but there's no actual, instead of violating conservation energy, you're violating conservation momentum. So the way that a normal rocket works is it shoots exhaust out the back, and then the rocket goes forward. So you're balancing the motion. So the motion of the rocket is balanced by the motion of the exhaust. Now, the exhaust, of course, is a lot lighter than the rocket, so it has to move a lot faster to balance it. But still, there is that balancing out. The momentum is conserved. So that's essentially how all propulsion systems work, except for this one.
So how come the microwave can't put out like an exhaust?
Well, that's the thing. No one knows. That's kind of the trouble. It does break our understanding of the laws. It shouldn't work. And this is a huge problem, obviously, because this is like a pretty important basic law of physics. It makes it actually very difficult to analyze how something works when it violates the laws that you normally use to analyze how things work. It's hard to come up with an explanation if it's violating all the rules you used to do it. Like, for instance, actually, you mentioned perpetual motion machines. Many years ago, I was asked by someone who had invented a perpetual motion machine to kind of explain why it wouldn't work. And it was actually quite difficult to analyse all the forces on it. It looked like one of those imbalanced things that the force should keep pushing it around. So I did a mathematical analysis where I could calculate the forces on a net force on each point and then explain why it didn't work the way it would appear to just by looking at it. But to calculate those forces, I actually had to calculate the potential energy of the things that moved around. So I essentially used conservation of energy to calculate the forces on it when this thing that was supposed to be violating conservation of energy. So in some ways I cheated. I mean, it was actual real physics what I was doing, but it was kind of cheating. When you've got a thing that's supposed to break the rules, then how do you analyse it using those rules that it's going to break? So that's the problem you're up against. It's going to be awfully inconvenient if this thing is true. Not to say that it isn't true. I mean, they've tried to come up with some explanations for how it works. In this recent paper, they talk about, they spout all this gobbledygook about it pushing against the quantum vacuum. It's hugely speculative. So the idea is that
What's the quantum vacuum?
Well, the idea is that the empty space in quantum physics is not really empty. It's full of virtual particles briefly popping in and out of existence. The ground energy state of the universe is not zero. There's a certain energy there. It's known as dark energy in cosmology, you may have heard of. It can have actual effects in quantum physics, but it's this kind of weird, mysterious thing, and so people like to invoke it to explain anything that cannot be explained. So perpetual motion machines, they often say they get this energy from the quantum vacuum. Homeopathy, they say, it's interacting with the quantum vacuum. Everyone blames the quantum vacuum because they think, I'll just throw the word quantum in there and hopefully no one will understand what I'm saying and I'll get away with it. And that's essentially what they're doing. They go through this big long explanation about a particular interpretation of quantum theory and then going, and so maybe the quantum vacuum is like a kind of a fluid and there's waves in the fluid. I don't know. As far as we know, it doesn't work that way. It's a hugely speculative thing. It's basically gobbledygook is what they're saying. I don't have a high opinion of that, but that's the best explanation that anyone's come up with.
But if you can't disprove it,
then... Okay, but the thing is...
You can't disprove anything.
Well, if you can't prove an alternative or prove a reason why it wouldn't work.
Well, this is okay. So the thing is, I think you have to come up with a plausible explanation for how it works. I think in this case, particularly because you're breaking fundamental laws, you can't just chuck out those laws. You need to kind of say how you're going to replace them, how you're going to tweak them as a result of this.
Like how they're accounted for.
And you also need to convincingly rule out any other explanation. This is the whole extraordinary claims require extraordinary evidence, the saying that Carl Sagan used to say.
Yeah.
In this particular experiment, they talk about all the other possible sources of error. The main one that people are looking at is essentially thermal expansion. So basically, when this thing heats up, as it does when you switch on the microwaves, then it does move slightly as a result of the thermal expansion, and that is much bigger than any forces of thrust. They try to subtract this in their analysis, but they admit that maybe there's possible next thing there, and they have some suggestions how you would improve the experiment. So that sounds like the most likely explanation is going to be some sort of thermal effect. There's a few other kind of weird interactions with the environment that could be happening with this thing. The electromagnetic fields could be pushing against something else. They could even be giving off like gases or something like that as a result of the heating. There's any number of things that could be going on. You have to convincingly rule out those things. As one analysis of it I saw said, it's actually really hard to have completely zero thrust at all, because you just put something down, weird fluctuations, thermal fluctuations, it's going to kind of wibble around and this kind of thing. So getting absolutely zero and having a benchmark of zero is actually quite difficult. So look, it's basically someone needs to do more experiments, better experiments to do it. I mean, the type of thrust they're getting from this, it is quite small, I should say. What they observed was in the range of 30 to 128 micronewtons. Newton being the measurement of force, named after Isaac Newton. He rears his head. We're violating his laws and he's still involved here. That is about the equivalent way to say a 13 milligram mass. So you imagine holding a mass weighing 13 milligrams. That's a level of force pushing that would
you barely notice you were holding anything.
Yeah, that's right. So it's not a big force, but if you had, for a rocket that uses no propellant, you can keep that going, indefinitely. It's pretty impressive if it actually works. So look, I'm not saying it definitely doesn't work. It's just I think we need a bit better explanation, and we need to completely rule out any other problem. We need to really figure out how it's working, because I think if you wanted to build a rocket out of this, you'd need to know how it was working so that you could actually make it work better. Because until you know how it works, you can't really optimize it. You're just basically building a box that does something weird and then saying, ha, I built a weird box. But anyway, we'll keep watching this one, but don't expect that you're going to be magically flying to Mars anytime soon.
Science, the final frontier. These are the voyages of Lost in Science, our ongoing mission to explain strange new words, to seek out new science and new explanations, to boldly go where no radio has gone before.
So if I ask you guys about STEM, what would you say? What would you think I was talking about?
I know what you're talking about. Science and technology and engineering and maths.
That's exactly right. I'm not talking about plants. Although, plant science is part of STEM. But yeah, it's an acronym for science, technology, engineering and mathematics. And the reason that this exists as a thing is that over recent years, enrolments in tertiary and higher education courses in these particular fields of study have been declining.
Even engineering?
Engineering's doing better
than the others. Okay.
It depends where they draw the line, because engineering also includes some parts of construction, and the building industry and things like that are included in engineering. So engineering is kind of a bit amorphous, I guess, compared to other sciences a little bit.
It's not really science.
Well, it's an applied science. I mean, it's kind of applied physics, really, in a way.
Yeah, okay,
Engineers are people too.
But are they scientists?
Yeah.
But look, so
No, I don't want to offend any engineers out there. I mean, you're all wonderful people, and I'm just joking.
It'd be hard to do science without some engineering involved at some point. But basically, the idea of STEM, science, technology, engineering and mathematics, was that these are very important skills to have in the community, and this is how we, actually generate innovation and all those sorts of things. But what we've actually seen in Australia particularly is that if you trace back the educational history of students enrolment in science subjects over a wide range of fields has been falling since 1992. So that's over 20 years. Now, the percentage of students studying physics in their final year at school was around about 1 in 5 students in 1992, and now it's down to only 3 out of 20 students in the last few years.
Well, hang on, Dr. Einstein. How does that equate? 1 in 5 is about 4 out of 20, so it's down to 3 out of 20.
Yeah.
So that's not that's...
Yeah, but it's a decline, and it's if you look at the percentages are much bigger numbers. But I was just and even in biology, about a third of students in 1992 studied biology in their final year at school, and now it's less than a quarter of students studying biology in their final year at school. So that's a significant they're in decline, and that's I guess people think of biology as maybe one of the softer sciences, whereas physics is maybe
hard.
seen as hard science.
Biology's for nice people.
Well,
I think that's what you're saying.
It is what I'm saying. Biologists care more about plants.
Yeah,
and
biologists are
animals
the best.
living things. But one of the things they did notice too is that across the board that more male students are enrolled in physics subjects and more female students are enrolled in biology subjects. But look, this is falling across the board anyway. So there's less people doing physics, and there's less people doing maths, and there's less people doing biology, less people doing other sciences. So psychology students are falling, all those sorts of things as well.
We're talking high school, are we?
High school, yeah. But obviously
this is year 12, these last
year
years.
12 or the final year of high school.
Yep.
But this tallies with science enrolments in university courses as well, because if you don't study science in high school, you're not likely to go and study science at university. For one thing, because you need prerequisite subjects to get into certain courses. So if you didn't study it in high school, you're going to have to do a bridging course, or there are options, but it's a lot more difficult to get into a science course in university.
You'd also imagine if you weren't interested in doing it at high school, you're probably not going to be. No.
Yeah.
Yeah. Well, yeah, exactly. If you're not inspired to study it, you're not going to look at those courses. You'll be looking at other things. But so with STEM enrolments failing, obviously the future of scientists in Australia will have to basically import more scientists from overseas if there's jobs for them to be employed in.
I have 2 questions for you, Stu.
Yes.
Do you, 1, know what fields have been then scooping up these students? And 2, do you know why they're not choosing STEM courses?
That's the tricky part of it, really, is knowing why they're making these choices, and it's it'll be a number of factors, but I think
no jobs.
There are a lot of technology jobs, but there's not necessarily for example, there may not be a job as a physicist, for example.
No.
But in computer science and information technology,
engineering,
chemistry, engineering, and biology courses lead into other things as well. So if you wanted to say work in vet science, or if you wanted to work in medicine, those kind of courses
physiotherapy,
are
anything
building
like that.
up courses. So.
Well, interesting you bring up biology as well, because medical research is one area of science where Australia does put a lot of money into, definitely. So that's something where presumably there's been a continuing demand for employment in that area, yet my information from what you're saying is there is a reduced supply then.
Well, we're actually doing okay for doctors, but peripheral health sciences are finding shortages of people.
Really?
So health sciences in nursing and other professions related to medicine. But the other thing also with doctors is that there's more doctors than there used to be, but there are more specialists than there used to be and fewer GPs. So it's harder to find a GP than a specialist in a lot of areas. So as I said, the STEM also includes engineering, which Australia actually has low enrolments in engineering compared to the OECD average.
That's why it sounds bizarre to me, because I know back home in Canada, engineers, there's just tons of it. It's probably in our universities, we don't really specialize necessarily in one field or another, but the engineering departments tend to be the most high in demand and the most lucrative. They're just they're just swimming in money.
There are a lot of jobs for engineers.
Exactly, yeah. So that's why it's surprising
some of the other, trying to get someone to do a pure maths degree is pretty tricky because I don't know exactly what you do with a pure maths degree unless you...
There's not a job at the end with a label. Like, you can't just put a name on it at the end of the day.
You'd probably end up maybe working in finance or something like that rather than... trying to solve equations in a lab with a blackboard or whatever it is that mathematicians do.
I've seen a few movies about mathematicians. They end up going mad generally, I think.
Oh, does their hair all stand up on end?
And it's really, really white.
Yeah. So Australian students do have a slightly higher than average interest in science, but as in compared to other countries, but the percentage of students who show high scientific literacy when they're tested is also falling. So the level of understanding of science, which is possibly part of the reason that they're not enrolling in these courses because they don't get what they're being told already. They're not understanding the basics of the science to want to go and study further. So in our immediate region, Australian students are trailing behind 3 separate regions in China. So they split China up into smaller parts so they could test across there. We're behind Korea and Japan and Singapore in terms of scientific literacy that students can demonstrate when they're tested, which is a bit of a worry. So, look, and I guess part of the other reason it may be difficult to convince students that it's worth studying sciences is that, it's hard to say, well, this is the job you get at the end. Yeah. If you go and study accountancy, you say, here's a job, you can be an accountant.
Yeah, exactly.
If you study particle physics...
You don't really know.
I don't really know what you would end up doing.
Yeah, you're looking at it. Stop picking on the physicists, though.
Well, sorry, I don't mean to pick on physicists. It's just that that is because physics. A lot of people do find that challenging and confronting. It's like, well, why do we have students studying physics?
But it's surprising because I would think that a lot of these choices of what you decide to do in university or in post-secondary would kind of come with like this idea of what's the job at the end of the day. So if I put in my 4 years, I can get a job at the end of the day, or my 3 years. But then with a lot of these science degrees, with physics or with biology or with chemistry, often you need a master's or a PhD, or you end up going to school for a bit longer than you would have thought so in high school. So maybe that's the deterrent. But then if you're telling me that, like, so medicine's probably increasing, but like engineers or people in technology and things like that, these are jobs, these are paths that lead to a job.
Yeah.
So
even in computer science and information technology, the enrollments are falling.
Yeah, see, that's what I mean. That's the surprising thing, because these are ones where you can do your 3 or 4 year course, have your university degree, and potentially get the job at the end of the day, and not require the master's or the PhD afterwards. Yeah,
without any data to show for it, I can imagine that the last 20 years or so that you're talking about there would have seen a rise in other vocational related courses that require degrees. Things like I don't know, your business courses, your event management, those kind of things, and many of your, we're talking about computer courses. That's like expand into web stuff and
programming and all that.
Well, I'm thinking more like your creative things as well, like your animation graphic design. So there's been extension of new jobs and new professions that require qualifications. So there's more enticement for people into other areas.
Maybe that's the thing, that like the numbers are declining because the options are increasing. So there's other places that people can go. So maybe before.
Again, I don't have the data. I'm just saying.
Yeah, but
and also the money.
Yeah.
If a job is paying better, then students are more likely to go for that kind of course, which ends up with a better paying job because you end up with a HECS debt at the end of it, or a debt that you've got to pay back for your tuition and all that sort of thing.
You'd only hope that people are that forward thinking. I wasn't when I started.
Having said that, there's it's sometimes hard to relate what the job is at the end, and one of the examples that people often use is that you never know what useful practical applications are going to come out of things which seem to be studying something with no direct practical application. So the guys who filed the patent for the Wi-Fi technology at CSIRO were actually studying black holes. They weren't looking for Wi-Fi technology. That wasn't part of their goal to study. That was something they figured out on the way to being able to study what they're actually interested in. So, there's things like that which sort of offshoots of trying to figure something out, and you have to come up with new ways of looking at things. So that, that's an example that people sort of use quite a lot. But if you look at applied sciences, it's a bit more worrying that they're declining. So if you look at something like forestry, so there's a huge potential for forestry to be used in climate stabilisation and carbon sequestration and all that sort of thing. There's less than 100 students in the whole country studying forestry as a science. So you would think that would be a booming area for people to be, interested in, at least, enough to go and study it, but they're not enrolling in these courses. So there's not actually that many people who know much about forest science who can actually help with that sort of thing. So that kind of surprises me. And I do think also that, you hear politicians all the time talking about innovation and how the jobs of the future don't exist yet, and, we don't know what they're going to be and all that sort of thing. But one thing I'm pretty sure we can be quite convinced of is that they're not going to appear out of nowhere. They're going to be jobs based on stuff we already know. Jobs, yeah. So to build up to the level of these jobs that don't exist, it's probably a good idea to have people who are studying the basics of science and technology and engineering and mathematics, so that they will be equipped to deal with those new jobs that don't yet exist. Because, as I say, they're not going to appear out of nothing. They're going to be based on stuff we already know how to do. And if you already know how to do something, you can figure out how to do it better, just like with the EmDrive, I guess. If you don't know how it works, you can't figure out how to make it work better. So I guess the timing of this is basically that, students are getting their results. You year 12 and final year students in high school are getting your results, and maybe just have a look at your preferences and figure out if maybe there's a science course that you could do to bring those science student enrollment numbers up. And, even if you don't want to do a complete science course, maybe just there's probably a subject or two you can squeeze in there somewhere, just try it out. Science subject, and see if you like it.
Okay, that is it for another episode of Lost in Science. Lost in Science is, of course, recorded at the studios of 3CR in Melbourne. It is across Australia on the Community Radio Network with the support of the Community Broadcasting Foundation. We would love you to get in touch with us. Please email us at lostinsci@gmail.com, or you can find us on Facebook, where we are Lost in Science on 3CR, or you can find us on Twitter, where I think we are at Lost in Science 1, or you can find our podcast on various podcasting apps and that sort of thing, or you can listen to us next week, same time on the radio, when once again Manisha, Stu, Claire and Chris will get
Lost in Science!
Thanks for listening to a 3CR podcast. 3CR is an independent community radio station based in Melbourne, Australia. We need your financial support to keep going. Go to www.3cr.org.au for more information and to donate online.